Hello guys, welcome to another session of Math. I hope you guys are doing good. Alright, today we are going to look at another definite integral problem. This problem here is a little bit different from what we have been solving, but not all that different. The only difference here is that this problem here came with a stated approach of what solving it. That is, the problem here went further. We can solve this problem by using what this approach, or the question says we should solve this problem here by doing substitution of u is equal to e raised to the power what minus x. Okay, so because of this substitution that the question says we should do from the scratch, or from the start of our solution, it makes it a little bit different from other questions that we have been solving, because as for the other ones, we have to decide the approach and then decide how to use the approach. Even if we are to use the substitution approach, how are we going to do substitution? Are we going to let u be equal to the whole of this, or what? Well, that is what we have been doing, but this question here says we should solve this problem here by letting u first, by using a substitution approach, but not to do any substitution just like that, but rather use the substitution approach by letting u be equal to e raised to the power what minus x. Okay, so that is what we are going to do, and that should be our what first step. Okay, all right, now that we know what we are going to do, how the substitution is going to be done, why don't we get started? So let's write our solution first. All right, so let's bring this question down here. All right, 1 over 1 plus e raised to the power minus x dx. Now, as you all can see, the question says we should solve this problem by using what substitution of u is equal to e raised to the power minus x. So we are not going to do any substitution, but rather u is equal to e raised to the power minus x, and that is going to be our first step. Okay, and by doing that, what the question is expected of us will be what one way or the other accomplished. Okay, if you don't do that, or if you don't see that in your solution, meaning you deviated, you didn't go what the question, and didn't stick to what the question was saying, or what the question was expecting of you, was expecting you to do. Okay, so let's do a substitution as the question says. All right, so u is equal to e raised to the power minus x. Okay, here to continue, how are we going to do it? We have started with u is equal to e raised to the power minus x, but how are we going to find dx in the u world? Well, you can use the reciprocal approach. That when you use the reciprocal approach for this one, you get the same answer as the natural log approach. Also, when you use as you get the same answer as the natural log approach will also give. Okay, so here I'm going to take natural log of both sides. Yeah, I'm going to take natural log of what? Both sides. I'm not going to reciprocate both sides before I solve for what? ds, but rather I'm going to take natural log of both sides, eliminate this one, and then get this one back, and then find what? Dx. Okay, so let's take natural log of both sides. Alright, when you take natural log of both sides, we are going to get that is natural log of u is equal to natural log of e raised to the power what? Minus x. Good. Let's focus here. Here is natural log of e raised to the power minus x. So how are you going to get x back, or how are you going to get x? Well, we know that the base of the natural log is what? E, and then we are having the number here is what? E. And from the laws of logarithm, when the base and the number are the same, it cancels out, and to be left with what? When they cancel out, to be left with what? This minus x here. Okay. Good. So this e and the natural log will cancel out, to be left with minus x. So you're gonna get natural log of u is equal to minus x. Okay. Here you can multiply both sides by minus 1 before you differentiate, or you can differentiate before you multiply both sides by minus 1. Okay. So by here we are going to differentiate first before we multiply both sides by minus 1. So when you differentiate natural log of u, you're going to get 1 over u du, and that is equal to minus dx. Now let's multiply both sides by minus 1. And when you do that, you're going to get dx is equal to minus 1 over u du. Now, when you use the reciprocal approach from here, this one can be written as 1 over u from the negative law of indices. This one can be written as 1 over what? E raised to the power what? X. And that is still be equal to what? U. And now let's reciprocate them. When we reciprocate, you're going to get E raised to the power minus X is equal to 1 over what? U. And then let's differentiate. If you differentiate it from there directly, you're going to get E raised to the power minus X dx equal to minus 1 over u squared du. And we know that e raised to the power minus x is equal to what? 1 over u. So it will rather be 1 over u dx is equal to minus 1 over u squared du. Then we multiply both sides by what? U, in order to get what? Dx. So when you do that, we are going to get dx is equal to minus 1 over u squared times u times what? Du, and u cancel out with u squared to be left with what? U, and that will give us the same thing as what? As the natural log as what? Giving us. Okay, good. Now we know what is going to replace dx, so this one will replace dx in the u world, and then also this one will replace what? E raised to the power minus x in the u world. But also we have to find those limits that were given in the integral. It's a definite integral, so when you make substitution, you don't have to leave them behind. What you have to do, you also have to find their values in the new world that you are going. I mean their corresponding values. If the value is what? 1 and 2 in the x world, what would be the value of 1 and 2 in the u world? How are you going to do that? First we know that u is equal to e raised to the power of minus x. So we are just going to replace this minus s here with what? 0 and what? Natural log. And whatever that we get will be for what? This u, because u is equal to this. Okay, so let's do that. So u is equal to e raised to the power minus natural log of 2. Now let's focus on this side. E raised to the power minus natural log of 2. This minus sign here will come and power this 2 from the one of the law of logarithm. That is the law of what? exponent. When it's here, it comes here, and when it's here, it gets back. Okay, so here is -1, so this one will be what? 2 raised to the power -1. And as we all know, another law of or property of logarithm says that a raised to the power log b with the base of, let's say, a will give you b, because the log with the base a and the base which is being raised to is what? The same is. So that a and that log with the base a will cancel out, and to be left with what? The b. Applying the same thing here. When you bring this one, you're gonna get 2 raised to the power -1, and the base of this natural log is e, and there's another e here. So this e and the natural log will cancel out, and you're gonna get u is equal to 2 raised to the power -1, and that one is equal to 1/2. So actually u is equal to 1/2. Good. Now let's put in 0 and see what we are going to get. So u is equal to e raised to the power -0. Don't confuse yourself with this -0 sign here. 0 is, let's say, 0 without any decimals, without any direction. I mean, though is this what here means is going maybe the negative direction, but actually they are not there, so we just assume it to be in what? The middle side. And when it's the middle side, maybe we say it's neutral unless it start moving, maybe -0.1, something like that. But this one is just 0. So e raised to the power -0 will just give us what? 1. Okay. So this one is going to give us what? 1. Alright. Now the value of natural log of 2 and 0 in the u world is what? 1/2 and then what? 1. Okay, so now let's completely enter the u world. Okay, now this is how it's going to look like in the u world. So that's 1/1 plus u times -1/u du. Now here we'll just bring this -1 sorry, at the back here, then we multiply this by this. 1 times 1 will give us 1. By here, what we are going to do that when you multiply this by the whole of the, you're gonna get 1 u plus u squared, and that is what? A quadratic. And what we are going to get at the end of the day will be 1/u plus what? U squared. And to solve that, we have to factorize, or maybe you have to use another approach, maybe tricks up or something like that, or maybe any other approach to solve it. But here I'm not going to multiply this one by this one directly, but I'll do something that will show that this and this are what? Multiplying. Okay, so it will be u into brackets, or u times 1 plus what? U. So I'll actually break this one and multiply it by what? The 10. That will give us what? U into brackets 1 plus what? U. Okay. Good. Now I did it this way because of the approach that I'm going to use right from here. I'll be applying the partial fraction. Maybe when you expand this one, u plus u squared, maybe you can use another approach to solve it. Maybe tricks up, maybe integration apart, or maybe something like that. But here I'm going to use the partial fraction to solve this one. That is why I didn't bother opening what? The bracket, because if I open the bracket and I want to use the partial fraction, I have to what? Factorize again before what? Apply the partial fractions. That is why I didn't bother what? Opening what? The bracket. Okay, so here we are going to use the partial fraction approach to solve. The partial fraction, there are 3 ways. We have the quadratic factor, the linear factor, and the repeated factor. The quadratic factor is always like after the factorization, what is in the bracket or what is outside the bracket, you always see a power of 2 on them. like this one. Maybe if assuming if this one is u squared into bracket 1 plus u, it could have become what? A quadratic factor. Or maybe u into bracket 1 plus u squared, it could have still become what? A quadratic factor, of which you apply what? The quadratic approach to solve it. Okay, and also with the repeated factor, it's like maybe if it is like this, you see some what in the bracket, what is in the bracket. You see that maybe if it something like let me say 1 plus u is in the bracket, and you can see that the whole of 1 plus u is being raised to maybe let's say power 2, like maybe the whole of this raised to what? Power 2. When you see something like that, it's what? A repeated factor. Okay, good. And then the linear factor is after factorizing what is in the bracket, you will see maybe no power of 2 or any power which is more than 1 on any of them that is in what? The bracket. So assuming, let's take this one for instance. You see, let's say after factorizing this one, the power of this one is what? 1. The power of this one is also what? 1. So the power isn't more than 1. So it therefore makes it what? A linear factor. And therefore, to use the partial fraction, we apply what? The linear factor. Even when you expand it, if this one is in its expanded form like u plus u squared, you have to factorize, and by factorizing will tell which type of partial fraction to use. Okay, after factorizing and you get some power 2, it means you're going to use the quadratic factor. Maybe the whole bracket being raised to power 2 means repeated factor. No power 2 or no the power not being more than 2 means you are going to use what? A linear factor. So here we are going to split it into a partial fractions by applying what? The linear factor approach. Okay, so we are going to split it into partial fraction by the linear factor. If you want to apply the linear factor, you take the first one and then you separate it by a plus, and then you take the second one. So it is, you take the first one, you form a fraction that is a over whatever variable that is there plus b over whatever that is there. By here it is what? U. So you're going to be a over u plus b over 1 plus u. You can also say that a over 1 plus u plus b over u. Addition and multiplication is what? Commutative. So anyhow you do it is what? Accepted. Okay, so let's split it into partial fraction. All right, let's split it. Okay, so by applying the linear factor of a partial fraction, this is what you're going to get. A over u plus b over 1 plus what they do. The a and b here, that is generally that is what we use, the variable that we use in terms of what? Partial fractions. When you are solving questions that involve application of partial fractions, we actually use what? A and then b. And then maybe we use the order of what? The alphabet. Maybe if you don't want to use A or B, you can use maybe C or D, right? Any variable that we use, but generally we just use what? A and then B, and in that order. Assuming if this one is, let's say, squared, the formula could have become ax plus b. But with the linear factor, the formula is a over the variable plus b over what? The other variable. Okay, so here we are going to find the value of what? A and then b before we integrate. Okay, and to do that, we are going to form what? An equation from this and also that. Okay, and how is the equation going to be formed? The equation is going to be 1 is equal to a into bracket 1 plus u plus b times what? U. And how did we got that? You know that this one came directly from here, so whatever that this one will give should be equal to this one. So actually the whole of this is equal to this one, and when you simplify this one, you're gonna get a times this plus b times this all over this times this. And when you do that, this one is equal to a by this plus b by this all over this times this. And you could see that both left and right hand side will have the same what? Denominator. And then since they are having the same denominator, we can easily equate what the numerators, or if you want to eliminate it, then we multiply through by what? U into bracket 1 plus u. And when you do that, this one multiplied by this one will give us what? 1. And then this by this plus this by this divided by this times this multiplied by this times this will give us what? This by this, and then plus what? This by that. Okay, so actually the equation is going to be 1 is equal to a into bracket 1 plus u plus what? Du. Now how are we going to find the value for a and b? Here we are not going to put u is equal to 1 and then half. No, we are not going to do that. But rather we are going to use what? The cover up rule approach to find the value of a and then b. And how does the cover up rule work? The cover up rule works says that just guess of any number which when plug into the equation will eliminate one of the variables and leave one for you to work on. Okay, so here we are going to come out with any number. I mean, the number that we will come will be for what? U. So we're going to come out with any number which one that we put into this equation we either take away a or take away what? B, and then leave either a or b for us to work or for us to find the value, after which we what? After which we what? We repeat the same thing to find the other what? Variable. Okay, so what number are we going to use? See, let's look at this side. B times u, mainly when we put u is equal to 0, we can eliminate b because b times 0 will be what? 0. And then here when you put 0 here, a will not be eliminated because here is being separated by what? Plus. 1 plus 0 will give us what? 1. And a by 1 will give us what? Just a. So when you put u is equal to 0, b will be what? Eliminated, and to be left with what? A for us to work on or to find the value of what? A. So let's put u is equal to 0. Alright, so let's replace this u with what? This 0 here, and let's see what you are gonna get. Good. Now after replacing 0, this is what we have gotten. Here this times 0 will be what? 0, so we just ignore it. And the 1 plus 0 is what? 0, and then a times 1 will give us what? 1. So we're actually gonna get 1 is equal to a. So a is equal to what? 1. Now by putting u is equal to 0, we have gotten the value for what? A. Now let's look at b. What else can we do? What number can we also use? From the original equation, is 1 is equal to a into bracket 1 plus u plus what? Bu, and then we just replace u with 0, and then we had the value for what? A. So what else can we do? Maybe when we let u be equal to -1, that one is going to also help, because when you look at the a side, we are having 1 plus u. So when u is equal to -1, A will be eliminated and then it will be left with what B, and then we work on what B. So let's put U is equal to -1. Good. So let's replace it. Good. So this and this will give us 0. This by 0 will give us what? Nothing. So let's ignore this. This one will be 0. And then here will give us what? -B. So 1 is equal to -B. So B is equal to what? -1. Good. Now the value for B is what? -1. And the value for A is what? 1. So let's replace A and B with 1 and then -1 respectively. Good. Now here, what we are going to do here is that we're just going to integrate and then find the actual value at the end of the day. But before we do that, you see this minus sign here. This minus sign here, we can integrate this problem at the end of the day, then we multiply through by this -1. It's actually -1, but we don't indicate the -1 actually. So then we multiply through by what? -1, and then we are good to go. And also there is another way. Sometimes when you get this minus sign at the back here, you can use this -1 here to interchange the position of what? The limit being given. If it is a definite integral and you have gotten maybe -1 at the back here, you can use that -1 to interchange this 1/2 and this one here. That is, you bring this one to this side and you bring this one to this side. And is that one possible? Yeah. I'm going to show that one in this video for you guys. Okay, so here I'm going to work out the value in two ways. One, I'm just going to maintain this minus sign here and then use it to solve this integral, as we all know. And then the other one, and then in the other section, I will use this minus sign here to interchange the position of my 1/2 and then 1. And then we solve and we find the actual value. Then we compare the answer that we get from this one and then also to the other one and see if they are the same. When the answers become the same, it means that when you get minus sign here, you can use it to interchange the position of what? This and then that. So here what I'm going to do is that I'll actually not integrate this one and then later multiply through by -1. No. This one is minus, so I'm just going to use this one to expand this or to multiply through the whole of this. And when I do that, you see this one is minus, so it will become plus, and this one will become what? Minus. So actually going to be this minus what? This. I'm just going to multiply this by a minus sign through here, or this minus, so I'm just going to multiply it through. And when I do that, this is what I'm going to get. This one is negative, so when you multiply by minus, positive, and then this one times this minus, you're going to give you what? Minus. Alright, so now let's integrate. What is the integral of 1/1 plus u? That one is what? That is natural log absolute value of what? U minus. Now what is the answer to this one also? This one also will give us what? Natural log absolute value of what? U. Good. Yeah, as you can see, there should be some vertical line here, which this and this should be what written on, but it's not there. But that shouldn't be a problem. We know that since a definite integral and we have gotten the expression, what is the next step is to replace those values into the expression and then find the answer. Okay, so we are going to put u here. Now that we have gotten our answer, we're just going to replace this u with this 1/2 and then what? 1 here. Okay, so but the formula says after you are done with the integration and you want to find the numerical value, this is what? upper limit minus the lower what limit. So we're going to first put this minus half into the whole of this, and then we subtract after putting this one into the whole of this from the first one. Okay, so let's find the numerical what value. Let's put minus half into this expression, and then let's replace it with this one also. Okay, good. So as I said, it is what upper limit minus what lower what limit. Now after replacing u with what 1 over 2, this is what we have got. That is 1 plus 1 over 2, and here is what u. So u is what 1 over 2. Now let's look at this side. This times this will give us what this plus this. 2 times 1 will give us what 2, and 2 plus 1 will give us what 3 out of 2. So this one will give us what 3 out of 2. And this one here can also be written as what 2 raised to the power. Actually, to give us the same 1 over 2 here, but you just rewrite it because you're just going to get another answer here. Yeah. So this one can be written as what 2 raised to the power what minus 1. Okay. And mind you, because actually with the numbers that we are working on here is positive, you don't need the absolute value what again. Yeah, 1 plus this one is just positive, so we don't need the absolute value. So actually this one just give us what natural log of what 3 over 2 minus natural log of 1 over 2, or natural log of 2 raised to the power minus 1. Now when we come here, 1 plus 1 will give us 2, so we don't need the absolute value. So here will be natural log of 2 minus, now natural log of 1 is what 0. Natural log of 1 is what 0. So we just ignore this part. So when we open the bracket, we are going to get natural log of 3 over 2 minus natural log 2 raised to the power minus 1 minus natural log of 2. The absolute value has changed to what bracket because we now know is what positive, so there's no need for us to what maintain the absolute value sign on it again. Okay, all right. Now I will write the other part because I had the other side we had what natural log of 2 here. So when we write the other, that is we write 1 over 2 into this form, and then we apply the law exponent of logarithm. We can eliminate this and then that. Okay, so here this minus 1 here will come here, and it will be minus, and that will be plus. So actually we're gonna get natural log of 3 over 2 plus natural log of 2 minus natural log of 2. Yeah, as you can see, by rewriting natural log of 1 over 2, we've gotten this side and this side, this one and the other one also to be what the same. So this will cancel out with what this one, and it will be left with what this. So the answer is now what natural log of 3 out of 2. Natural log of 3 out of 2. Yeah, you can choose not to bring the bracket, nobody cares. Yeah. Now this section we didn't use the minus sign to interchange the position, and remember I said I will show you this part, and I'll also show the other part where I will use the minus sign to interchange the position of the limit, and then we find the value, and then we compare the two answers. If they are the same, then it means that when you get minus sign, you can use it to interchange the position of the limit, provided it's what a definite integral. Okay, so let's look at that side. Good. Remember I said that one when we reach this side in the other section. So here I'm not going to multiply this one through, neither am I going to integrate this one and multiply it through the final answer. No, what I'm going to do is I'm just going to use this minus sign here to interchange the position of what this minus half, this half, and then 1. So that means this 1/2 will come to the 1 position, and this one will go to what? The 1/2 position. Okay, so let's do it. You see, when you can use the minus half to interchange the position, and when you do that, it won't affect what you are actually integrating. If you want to quickly do away with this minus sign, that is another way of what dealing with this. You can use it to what? Interchange the position of what? The limit. So here, as I've done, here will be what? 1, and then here will be what? 1/2. But remember that here it was 1/2, and then 1 is what here. But now the 1 has come to the upper section, and then half has come to what? The lower section. That is what the 1 has gone to the upper limit position, and the half has also come to the lower limit position. But how is this one true? Well, you're going to find out from the answer that we are going to get at the end of the day. If give us what a different answer, then it means that what I just said is not true. You can't do it that way. Okay, but when you give us the same answer, then it means that when you get minus sign at the back here, you can use it to interchange the position of what the limit being given. Okay, so now let's integrate. This one will give us what? Natural log absolute value of u minus natural log absolute value of 1 plus u. Good. Now what are we going to do? Now let's put the figures into the expression and find the actual value. Now remember, upper limit minus lower limit, or upper bound minus what? Lower bound. And now after changing, 1 has gone toward the upper limit position. So we first put in what? 1, and then we subtract what? Half after putting half into what? The expression. So when you put 1, this one will be 0, and here will give us what? 2. Actually it's positive, so we don't need the absolute value or sign. So here we go minus minus natural log of what? 2. And then when you come here, this side is natural log absolute value of 2, and it's positive, so we don't need the absolute value again. And so this one will give us what? Natural log absolute value of what? 1/2. But we have gotten natural log of 2 here. We can either rewrite that one to get this one, but rather we're going to rewrite this one. Okay, so this 1/2 here can be written as what? 2 raised to the power what? Minus 1. Okay, now when you come to this side, 1 plus 1/2 give us what? 3 out of what? 2. Okay, good. Now here is minus natural log of 2 minus natural log of 2 raised to the power minus 1 plus natural log of 3 out of 2. Now this minus sign here from the exponent law of logarithm will come at the back here, and it will be minus minus, and it will be what? Plus, and it will be plus. Okay, so when we bring this minus sign at the back here or in front of this L, it will make what? It will change from what? Minus to a positive. And when it happens like that, this and this will cancel out, and because this one is negative and this one is what? Positive. Okay, so this and this will go away. And when it happens like that, what are you going to get at the end of the day? That is what? Natural log of what? 3 out of 2. So you see, either when you use it to change the position of the limit or not, you're just going to get what? The same answer. Okay, so after using it to interchange the position of what? The 1/2 and the 1, we have gotten the same answer as we didn't use to what? Interchange their position. So you see, so anyhow you deal with it, you're just going to get what? The same answer. Okay, so therefore integral which goes from 0 to natural log of 2, 1 over 1 plus e raised to the power minus x dx is now equal to natural log of 3 out of 2. Natural log of 3 out of what? 2. Yeah, so that is the answer to this integral question here. Okay. Yeah. All right. That's it, guys. Please, if you like this video, kindly give it a thumbs up, subscribe, and comment. Thanks for watching, and I'll see you in another video. Bye for now.